Hello everybody, let's learn about spits and bars. They are coastal landforms formed by two processes that are longshore drift, the transportation of material along the coastline, and also deposition. So let's get going. So here we have our coastline, and you can see that we've got the land, the sea, this is a beach here, and we have a bay with a river flowing into it. Now the waves are hitting the coastline at an angle, an oblique angle, and that will drive the sediment up the beach at an oblique angle with the swash, back down at 90 degrees under gravity with the backwash. That repeats, moving sediment along the beach over time. And of course, we know that process as longshore drift. However, at points in the coastline, there is a dramatic change in direction of the coastline. And at places like this, longshore drift will continue and material will be deposited out to sea, forming new land. This process continues so that that narrow finger of new land is built out into the sea. And that narrow finger is called a spit. At times, the wind direction will change, and this causes the spit to curve inwards as the direction of longshore drift is changed. But that doesn't usually last for very long, and then the wind will resort to its original prevailing direction and start to build the spit once more out into the sea. Let's have a couple of questions around that. What process is driving the sediment along the coastline? That's right, longshore drift. What is required for the sediment being transported by longshore drift to start building out into the sea? Good. A change in the direction of the coastline. Why does well, let's start off with, first of all, what is the name for this narrow finger of land that is building out into the sea? Very good, it's a spit. And what process is causing this material to build up and form new land that we're calling a spit? Yes, deposition, well done. So now, why does the spit have these curved ends every now and then? Good. The wind direction changes from time to time, and that will change the direction that longshore drift is operating in and forming these recurved ends. Okay, so far so good. Next, I need to draw your attention to this river that is flowing into the bay. It's quite a large river, and its current will continue out to sea. This means that deposition will only occur as far as the current, because at this point material will be transported out to sea. And so this is the limit of our spit. It is prevented from travelling any further out to sea by the river's current. Now, behind the spit, we now have a really calm and low energy environment. And all the very fine little sediments, like silt, can begin to be deposited because the energy is so low, and the waves are prevented from reaching this part by the spit itself. So all those little tiny sediments are deposited down and form a rich layer of mud and silt. And this builds up to form mudflats, which are very fertile and rich areas, but they're also quite salty because the sea is here. And we get a special kind of plant growing in these areas. They are tolerant to the salty conditions and the waterlogged conditions. And this is called a salt marsh. So lots of salt and lots of water on a fertile ground. Okay, a couple more questions. What prevents a spit from growing too far out to sea? Good, the current from the river. What are the conditions like behind the spit? That's right, there is low energy because there are no waves. And what happens as a result of that low energy? Good, fine material is deposited. And what forms after that material has been deposited? Very nice, yes. Mudflats and a salt marsh. Great. Let's just write some information in so that we're clear about what is happening. So longshore drift transports materials, let's say sediment along the coast. And this is our first stage of the formation of a spit. Our second stage is a sudden change in the direction of the coastline. And then the third point, which I'm going to just put here, is sediment is deposited out to sea, forming a spit. We can then talk about these recurved tips. That's a C. Recurved tips form when the wind changes direction. That's number 4. Number 5, we want to talk about the river current preventing further spit development. And finally, number 6, salt marsh develops in low energy environment. Now we're going to put this behind the spit. Now we're going to return to this in a minute, and you're going to make your own labelled version of this diagram. But I just want to show you quickly what can happen when there is no river in the bay, or maybe just a small stream entering the bay. In this instance, we have our longshore drift occurring, obliquely up with the swash, vertically down with the backwash. Spit is built out into the sea, deposition occurring, longshore drift continues to move material along, wind direction changes, get a curved tip, wind direction back to normal prevailing, and there is no strong current to prevent the spit from continuing to build across the bay. So the deposition and transportation process of longshore drift all continue until the spit connects with the other side of the bay. So we get a long line of sediment joining one headland to another, cutting off the bay so that this bit of water in here is now slightly less salty, protected from the waves of the ocean, and so is much calmer. This is called a lagoon, the bit of water cut off from the main part of the sea, and this spit is now referred to as a bar, because it is a bar of sediment that has joined one headland to another. Okay, let me put this back on display, and you are now going to take some time to draw your own version and add in your own annotations neatly and horizontally. Pause the video, off you go.